In this video, we are going to look at vectors and vector addition. Hi, this is Sean Huang from the Physics Department. Whenever vectors are involved, it is useful to see or recognize a right triangle. In a given right triangle, there is the hypotenuse, the angle theta, the side that is opposite to the angle theta, and the side that is adjacent to the angle theta. Sine theta is the ratio between the opposite and hypotenuse. Cosine theta is the ratio between the adjacent and hypotenuse. And tangent theta is the opposite versus the adjacent. From Pythagorean theorem, we know that the hypotenuse is equal to the square root of the sum of the opposite squared and the adjacent squared. All this information is nicely laid out in section 1.4 of chapter 1. A vector is defined in terms of its magnitude and its direction. If we impose a coordinate system on a vector, the projection of the vector on the x-axis will give you the x component, and the projection of the vector on the y-axis will give you the y component. The vector A will then be represented in its component form. By drawing this auxiliary line, you can see a right triangle whose hypotenuse is the magnitude of the vector and can be calculated using the Pythagorean theorem using the x and y components of the vector. And the direction of the vector is given by the angle theta, which can be calculated using the arctangent function. There are two ways to do vector addition. The first is a graphical method, often referred to as the head-to-tail method. It is very easy, but to see why it works, you first need to know that a vector is translationally invariant. This translation is not a language translation, but a geometry translation, which moves every point in a vector by the same distance in a given direction. And the vector will remain the same, or invariant. So we can move a vector any way we want, so long as we maintain its magnitude and direction. Then, in a head-to-tail operation, we will move a vector so that the head of one vector meets the tail of the other. We will then draw a line from the beginning to the end, and that will be the resultant vector. Vector addition can also be done using the component forms of the vectors. When given two vectors in their component forms, we simply line up the components, add the components together, column by column. The result will be a vector in its component form, for which the magnitude and direction will again be calculated using the Pythagorean theorem and the arctangent function. Vectors and vector addition are very common in physics. Look forward to examples where they are needed, and come back to this video when you need to.